Good morning, good afternoon, everyone. We have the talk ahead of us delivered by Frank Delporte, and the title is visible here, but I'm gonna quote it. How the new foreign function, the memory API, pushes Java on Raspberry Pi to the next level. Unfortunately, we have just 35 minutes for the presentation and further questions, so please do not hesitate. Enter those questions in the chat window. Of course, start with the letter Q like question in square brackets. Without further ado, Frank, the floor is yours. All the best.
Okay, I just restart. Okay. Okay, so I still hear someone in my admin. Can you please mute the microphone?
Sure.
Okay, thank you. So let's restart. My presentation is about the foreign function and memory API. I will have to go a bit faster because we already lost some time. You can find all the links of this presentation on my blog, webtechie.be, so you don't need to copy them. And I will explain to you why this kind of code is no longer needed in projects where you want to combine Java and C libraries. So this code that you see here on the screen, which I don't understand. I'm a Java developer. This is not the kind of code I want to read, debug or improve or write even. But it is part of the Py4j library, which is intended for Java developers to control devices connected to Raspberry Pi, meaning a LED, a button, whatever that can be controlled through a Raspberry Pi can now be controlled with Java. But inside this library, this black blocks that you have here, there is a lot of C code there, C libraries. But to be able to use them from Java, you have this complicated code. And this complicated code can now be simplified a lot thanks to the FFM API. The FFM API, which wants to provide a way to safely access memory directly off heap, meaning it's not touched by the garbage collector of Java. It also wants to provide a native interoperability, so that means that you can easily use these C libraries, but directly from Java, without the complexity of JNI, so JNI, which is already there since Java 1.1. And it wants to do this in a high-performant way, so that means that it's at least as good as what you could do with JNI, and preferably even better. Who am I? I'm Frank Delporte. You can find me on GitHub. I love to use, write, and talk about Java and JavaFX. I write content for Fuj.io, the website for the Friends of OpenJDK, and also do the documentation for the Py4j project. And I'm a senior technical writer at Azul, where I follow up closely the releases of OpenJDK and all the evolutions going on in the Java world. So I'm not an FFM expert or a contributor even to that project. I'm just a curious person who tried out different things which were coming out of this project. 5 years ago, I've written a book about Java on the Raspberry Pi. The physical book is sold out, but the ebook, you can still find it on my website, and I keep updating it. And probably still this year or starting next year, there will be another publish of this ebook with the new Py4j version using this FFM API. Now, if we look into the evolution of Java, so there's 30 years of Java. My journey with Java started right in the middle, so 15 years experience with Java. But that also means that in those 15 years, I've seen this pretty amazing evolution from releases every few years to releases every 6 months on a very strict release cycle. We already know the dates for the next years when the new releases will come out, and how OpenJDK keeps evolving thanks to this release cycle and everything which is happening inside. For Fuj, for the podcast, I spoke with James Gosling, the creator of Java. An amazing talk. It's of course still available on the website. Please check it out if you want to know more about how Java actually started more than 30 years ago. Now, how Java OpenJDK evolves is actually through the OpenJDK project. So since already a long time, OpenJDK has been open sourced, so you can find the sources of the Java runtime and the language in this GitHub repository, so openjdk/jdk. There you find the sources with the smallest README file you can imagine. But you can just get the sources from here, compile this on your PC. I've done that on a Raspberry Pi, for instance. It's also described on my blog. And you can run the Java, which is now being developed already in your own computer if you want to. Like you can see, there are already 26 stacks of Java 26. So the version which will be released early next year. So you can already start using Java 26 or experimenting with 26 if you want to. Now, if you're interested in how OpenJDK evolves, you have to check the openjdk.org website, probably the most fancy layout we can now find on the web for a website. But what is interesting here are the projects. So I will jump to Project Panama. Project Panama is the mother of the FFM API. So within Project Panama, the goal of Project Panama is interconnecting JVM and native code. So the main goal was there. And one of the projects, one of the realizations of Project Panama is the foreign function and memory API. If you're interested what happens in such a project, you can join a mailing list, see what people are discussing, why decisions are made to do it in this way or that way. So this is a very interesting section of the OpenJDK website to take a look at. And another important one are the JEPs. So to explain this, so a project is something big, and as soon as it is defined, we will do it this way, they start adding functions or changes to OpenJDK with the JEP, and the JEP is delivered with a specific version. There are a lot of JEPs. I will go into details for a few of them, but it's important to keep in mind that this system exists. And I also need to show you this one. A JEP, which is delivered in a specific version of Java, can also be an incubator or a preview feature. That means it's not finished yet, but it is delivered and it is tested. It's well written, but it's not stable. It means the API can still change, or some functions can still be removed, parameters added or renamed, but it's good to use. What the OpenJDK community wants is that you test it and give feedback. Is this actually the thing you need as a new feature? Or should we do it differently? So if you want to use one of these JEPs, which is delivered as an incubator or a preview feature, you need to enable preview flags when you compile your code or when you run your code. And in IntelliJ, you can also do that with a checkbox. And then you can use these new features. Why I explain you this, I will show you in a moment. Project Panama. So as I said, this is the mother of the FFM API. The Project Panama wants to improve and enrich the connections between the Java virtual machine and well-defined but foreign non-Java APIs. So that's, here they describe, we want to use C libraries in a better way from within Java. And they also want to have an API that offers statically typed pure Java access to native code. So another way to talk to memory directly, replacing GNI and how GNI works. And why did they want to remove GNI? Actually, this is a quote from a colleague from me, Simon Ritter. You may know him as Speak Java on Twitter and other social media. I can't remember who it was, but I was talking to one of the engineers back in the Sun days and expressing my frustration with GNI being hard to use. That's when he said it had been developed that way to encourage people not to use it. So although they provided in Java 1.1 a way to do this, they made it pretty complex because they wanted to discourage this approach. But nowadays we see that we really need this kind of interaction between Java, native memory, and C libraries. So they wanted to have a better way, a simpler way than what they have provided with JNI. So JNI is there since Java 1.1. There were two alternative solutions on top of it, JNA and JNR. Problem here is that you see that some of these things, there were external libraries, so that's the first problem. They're not really part of OpenJDK itself. It was with runtime code generation. So not the best way, a bit slower than JNI, and that's where FFM comes into the picture. So it is part of JDK 22. That means you don't need a dependency. It is at compile time, it's safe, it's as performant as JNI or better, and it's also easier to use. So it really achieves all these goals of replacing JNI with something better. And here we see the relation between projects, Project Panama, the JEPs, and how things get delivered in releases. So Project Panama already started in 2014, and it took several years to discuss to try it out, have proof of concept code, try some things out, again, have a discussion. And then actually they started with JEP 3701, which was not delivered. So it was an incubator. And its first step was the foreign memory access API. So how are we going to access memory in a safe way? So they needed 3 JEPs to do that. Also, the foreign linker API, which actually links Java with C libraries, was delivered as a JEP, but an incubator or preview. And then they merged these two together, and they came up with the first FFM API JEP in this release. I think it was 15 or 16, and eventually only in Java 22, they reached a stable state, which was really finalized, it's finished. And that's when they delivered it, and you didn't need the enable preview flag anymore and could start using this FFM API. So if you look into this evolution of JEPs, so you see the first one was delivered in 14. In 16, you had both the FFM foreign memory access API and the linker API. And you see they go from incubator to previews. And then at some point, incubator and preview were removed. That meant in Java 22, it was released. It was a final thing ready to be used. I have a few code examples, but we don't have that much time. So I invite you to go to the blog post and get the code examples and try them out. But I do have a few examples here. The simplest one is, how do you access memory directly? So this example, by the way, I'm using Java 25 for this code example. That means another JEP from another project simplified the main method. So you can now execute this as a valid Java file. There is no package, there is no class here. The main is not static void, public static void, main string array args. It's just void main. So simplified, the same thing with logging. You can now do IO dot. You see no imports, nothing. This is valid Java code. What we do here is we have an arena. An arena is actually the connection with the native memory. By using a try block, that means that at the end of this code, this gets cleaned. So it's not garbage collected, but it gets cleaned up after we have used it with this try block. So I ask for a memory segment which can contain 5 Java integers. Then I get the address of that location in memory. And then I have here two helper method to write to memory. So I write some random values into that memory segment. So in each of those Java ints, and I read them back. I'm not going to show you any rocket science code, except maybe the first one, that first slide I don't understand myself. But this is a way to access the memory directly from Java. So not as a Java object, but really writing directly into memory. I also have a code example to do way, and there you could use a byte buffer or unsafe, the sunmisc unsafe method. But if it's called unsafe, why would you ever use it in your code? So probably a bad idea. And then there's also the JNI approach, but the JNI approach is so complex that there's actually no code in here. It's just describing how you should be doing this. Too complex. We don't want to do that anymore. Let me see what I have here. I have another method, another example which is available, which uses the linker, a native method, a C method. And this is probably the most complex way to a string length. I know this exists in Java. Of course, that exists in Java, but I just wanted to demonstrate how you could do that with API. So here again, we have a memory segment because we are asking, give me the string length method, which is available in the kernel of a computer. The linker API will find this method. We know that this one returns me a Java long value. So we know that it returns a long value for the length of the given string, and it expects a memory address where the string is stored. So what we do here is we have a string, we put this into memory, and then we call this method. It's a complicated way to do string length, I know, but it's a perfect example of how simple you can now C library directly from Java code. I have another example, and I did a screen recording of it, where I compare the Java 11 way of using a byte buffer, buffered image, and on the right where I use the memory segment of Java 25. And I try in both cases, I'll try again, I try in both cases to refresh the screen layout every 5 milliseconds. And on the right, you see that this is easily achieved. It's 5-6 milliseconds. And on the right, it's actually taking more than 50. So more than 10 or 11 times the same duration to do exactly the same functionality. So that's part of this example code. Okay. Now, how did this help the Py4j project? So as I said, we have this black bar in between. All this complex code exists. And actually, this is the full diagram of how Py4j project is organized. Again, you have this black border here, and that's where all the plugin code exists to interact really with the GPIOs. So in this black box, you can plug in a plugin, and that will use a specific implementation to interact with the GPIOs. And we had some which were working fine on the Raspberry Pi 4. Then we had the Raspberry Pi 5, which has a completely different hardware architecture, and Py4j didn't work anymore. So again, we had a new plugin specifically targeting the Py4j, the Raspberry Pi 5, fixed that. And now we have actually a plugin which works on all Raspberry Pis, but needs Java 25, and which is using the FFM API. So all the code around the black box was not touched, actually. Well, we improved some stuff, but it didn't need to be redesigned. It was just the plugin which we made to use the FFM API. So all the code of Py4j is available on GitHub, of course. And the important thing here is if you look into the libraries, you have these 4 sub-projects for GPIO, GPIOD, LinuxFS, PyGPIO. So these are the old ways of doing it. So if we go into this code, then you will see this kind of complex code. And we even need special Dockers to build this native code, compile the C library to something which Java can use. And if we go to the plugins, then you see that we have here an FFM plugin, but we don't have the library. So as soon as we start using the FFM plugin, and we maybe can even remove the old ones. We will simplify this project a lot because we don't need those Docker scripts anymore and this compilation of the native libraries. So that will make life for us as Py4j maintainers a lot easier. The FFM API was contributed to Py4j by Digital Smile. So he was already working on a YAVA22 example project. I found it, I asked him if he could use it in Py4j, and he actually contributed himself and made it fully into a Py4j plugin, and helped us to improve the whole project a lot. I showed you the code. So what we actually achieved, so this is this tree structure. So this is the old way. We had some Java code. Java code was calling JNI code. Then we had a JNI wrapper, which needed to be recompiled. Then we had the native library. And then we had a system call to the kernel. And actually, with the FFM API, we actually removed 3 of those in-between steps, making the whole thing a lot easier. And also performant, because that was one of the goals of the FFM API, be better or at least as good as JNI or better. And what we see here is that we have a very fast result if you want to check the input of a GPIO pin, which is actually a lot faster than what we had before. And this was using the file system, so that's, yeah, the results are even not comparable anymore. So we are hoping to release this very soon. Version 4, we are testing it. That's also why there's a lot of Raspberry Pis behind me. We are testing all these new plugin implementations. We have some final problems with PVMs, so that's dimming a LED, for instance. So that's what we are working on. And we also have some new members who joined the team, I think in August, September. And they are working on a drivers library, making it even more easy for everyone who wants to join or use Py4j to control, for instance, a LED screen, a joystick, buttons, and all this kind of sensors. Here next to me, a CrowPy 3. This is a very fun device which has a lot of sensors and electronic components pre-wired to a Raspberry Pi, so you cannot mess up the wiring because it's already wired. That's the 3rd generation I have here, but generation 1 and 2 did already the same. Very affordable devices, very fun to experiment with. And you just plug in the Raspberry Pi you wish with the amount of memory you want to put into there. It's based on existing code provided by students some years ago, I think 2 years ago or 3 years ago even, where they have implemented Java example code for each of the components in the CrowPy 1. I will show you a little example with an RGB LED. So that means that we have a red, green, and blue LED in one component. Let me switch to my screen again. So it's here next to me. And the code I will be executing, let me show you. The code I will be executing is this one. So it's a gbang file. If you've never used gbang, check it out. gbang.dev, I think the website is. That means that you, inside one Java file, you define which dependencies you want to use. So you don't need a full Maven or Gradle project. Because we don't have a release yet of Py4j4, I also have a snapshot link here, but that will disappear. And then I have 3 numbers. That's where the wires are connected of this RGB LED. And we just define them as outputs. And then we can do some things with it. Let me show you. I can execute this on the Raspberry Pi next to me. So if you see on the screen, I have this code open in Visual Studio Code. I now start it. And you should see it blinking. And it even blinks in Morse. But maybe it's easier if I show it here in the presentation with the video. It also shows Hello World in Morse because the Hello World application in electronics is blinking a LED. And someone contributed to this example a Hello World implementation in Morse, so that it's really a Hello World thing. And another one I'm using here is the distance sensor. So a distance sensor is reading a state of an input and also toggling an input. So you can see that we can actually measure a distance. That's the same way a bat is flying around. And I have another demo, but our time is a bit limited as we had a full start. It's actually a Vaden application. So Vaden is actually a very fun thing to do. I have to start it on my Raspberry Pi so I can show you. Okay, it's a Spring application. It's a Spring application which can interact with these components. So if I touch the Raspberry Pi, then you see that something changes. I can put content on the LCD display. I can measure the temperature in my office here. So all this kind of interactions is now possible thanks to this combination of Pi4J, Vaden, Spring, FFM API. So all these combined give you all these features. Okay. My time is almost up, so let me go to the conclusions. I invite you to check my website, check fujay.io and pi4j.com. If you are interested in this project to control electronics with Java, then check out github.com pi4j. You can already try out the snapshot. So we have builds whenever there's something committed to the develop branch. And you can also follow OpenJDK projects and JEPs, of course, on openjdk.org. That's it for now. I hope I could show you quickly what we are doing with FFM API in Pi4j, but also how you can use it to interact with memory directly and use C libraries, like, for instance, in Pi4j, but also if you want to do AI stuff or use a native library for any other kind of use case. Okay, over to Adrian again. Are there any questions? And otherwise,
yes, thank you, Frank, for the presentation. I've been watching the chat window, and I do not see any questions. But the presentation was very, very good. And because we're running out of time, I would kindly ask you. Yes, I can see the applause expressed, right, by the participants. Right, you can see those lights flying around the screen. And in the chat window, I have provided the URL to webtechie.be. And frankly speaking, a lot of fantastic knowledge there, resources. So go ahead and explore it. Frank, it was an honor and a privilege. Thank you for being with us. And to all of you, please do not forget to rate this session. Thank you very much.
Thank you.